number 10 is the one that some of you asked about. So I want to go over this one. You guys, I'm only going to do 2 examples. Okay? 2 examples. So number 10 is one of them. So using long division, I divide x plus the square root of 3 into x to the 4th. Now notice, what am I missing right here? I'm missing the x cubed, so what do I do? Yeah, plus 0x cubed minus 2x squared. What else am I missing? Just the x, so plus 0x minus 3. Okay, so that's how I set it up. Remember, it's important that when you're missing those terms that you put in a 0 for those. Okay, now, just so we can keep the spacing right, and so when we're adding and subtracting it, we can line them up, and it makes more sense. Okay, so you start off by asking yourself what question? What do I times x by to get x to the 4th? Okay, x cubed. So I go x cubed right here, and then I multiply x cubed by what? X plus square root of 3. So if I times x to the 3rd by x plus square root of 3, what am I going to get? X to the 4th plus what? Remember, I got to distribute. I got to times it by both terms. So what am I going to get? Okay, root 3 times x cubed, right? But not like terms. I can't combine them now other than just writing them together. Okay, so what do I do next? Okay, subtract. So I do that by changing the signs. So I'm going to change this to a negative and a negative. Okay, what does that do? Okay, the x to the 4th minus x to the 4th is 0. It should always do that every time, right? Negative root 3x cubed. Bring down the next term. Okay. All right, then what do I do now? Okay, what do I times x by to get what? No, it's always the first term. It's always the first term. What do I times x by to get this first term? What am I going to times it by, you guys? Negative square root of 3 times x squared. Negative square root 3 times x squared, right? So what do I times the negative square root of 3 times x squared by? By x plus square root of 3. Okay, what happens if I go negative square root of 3 x squared times x? X to the 3rd, yeah. It always should be the same as that first one, right? And I got to distribute it, so I got to times it by the other one. What's the square root of 3 times the negative square root of 3x squared? What is square root 9? 3. So it's going to be negative 3 x squared, isn't it? Because when I multiply square root of 3 times square root of 3, I get the square root of 9, which is 3, right? Now it's a negative, so it's a negative 3 and then x squared. Okay, what do I do next? Change the signs. I add. What am I going to end up with? X squared. Bring down the next term, which is 0x. Okay? So I ask myself, what do I times what by? What do I times what by to get what? Yeah, what do I times x by to get x squared? So what am I going to times it by? X. Okay, so I put plus x. So I times x by x plus square root of 3. What do I get? get x squared plus square root of 3x. Okay, now what do? Change the signs and add. It's like this. If I have 5 plus 2, or 5, I'm going to subtract. So, well, if I'm going to subtract, I just change the signs and add. It's the same thing. Okay, here we go. Negative root 3x brings negative 3, right? This is the last one. What do I times x plus the square root of 3 by? What do I times x by? I times it by the negative square root of 3. Okay, so I got to go back up here. Put negative square root of 3. Negative square root of 3. And I times it by x plus the square root of 3. So I'm going to get negative square root of 3x. And negative square root of 3 times a positive square root of 3 is going to be a negative 3. Oh, this one's working out too nicely. Too nice. It's too easy. Change the signs and add. What do I get, you guys? I get a remainder of 0. So what is my answer? Yeah, there's my answer right there. Is that what they have on the answer sheet? What did they write down as the answer? Oh. Oh, well, let's see. No, let's see. Oh, you know what they did? Oh, my word. Well, they factored by grouping here. You know what they do is they do a factor by grouping to get that answer. I don't know why we're going back to that. I'm not worried about that. That'll work. They did a factor by grouping. We could do it. Like, all I have to do is group the x cubed with the x, and then the negative root 3x squared with the negative root 3. And if I grouped them together like this, I could factor out an x here to get x squared plus 1. Wait, this might not be how they grouped it. And on this one, I could factor out a negative root 3 I could have factored out a negative root 3, and I would have end up with x squared plus 1. Okay? And then I could have factored out an x squared plus 1 and times it by an x minus root 3. Is that what the answer was? Yeah. They just factored it by grouping the answer. I don't know why they did that at the end, but unnecessary. Yeah, our answer's correct. They just factored it by grouping at the end. Yeah. Say that again. Yeah, you go 4 over x minus 1. Plus 4 over x minus 1. Okay. I'll do one more example. You guys want one more? Yes, we do. I'll just do one more. Number what? 3? Okay. Number 3? Well, number 3 should be harder than number 4. Let's do number 3. So I'm going to have x minus 5 divided into 3x to the 4th plus 4x cubed minus 2x squared plus x minus 3. I'll move this back down. Well, I'm going to put this right up here. Okay. So, you guys, I'm going to ask myself, what am I going to multiply x by to get 3x to the fourth? 3x to the third. So 3x to the third times x is 3x to the fourth. 3x cubed times a negative 5 is a negative 15x cubed. What do I do at this point? Change the signs and add. So I'm going to go right here, and this adds up to 19x cubed. I bring down the negative 2x squared. Okay? And then we start the process over again. What do I times x by to get 19x cubed? 19x squared. So I times 19x squared times x, and I get 19x cubed. And I times 19x squared times a negative 5. What is that, 90? Negative 95, I mean. Negative 95x squared. Change the signs and add. And I am going to get 93x squared. Bring down the x. I can tell we're going to have a remainder on this one for sure. Okay, now what do I times x by to get 93x squared? 93x. 93x times x is 93x squared. 93x times negative 5. Someone tell me what negative 5 times 93 is. 465, so negative 465x. Change the signs, and I add, and I get 466x. Bring down the negative 3. What do I times x by to get 466x? 466 times x is 466x. 466 times a negative 5. Help me out. Say that again. 2330. It's a negative, right? Negative 2330. Change the signs and add, and I get 2,327 as my remainder, right? So my answer is 3x cubed plus 19x squared plus 93x plus 466 plus what? Over x minus 5. Because we have to have that remainder in there. Okay? Is that what they had on the back of this one? Okay. That's how you do those. Okay, this assignment's due next time. But the other one is due today. Okay, you guys, today's lesson is written, the objective's written over here. Today we will learn how to add, subtract, multiply, and divide rational expressions. The nice thing about this is I've kind of already taught this to you back at the first of the year when we were actually solving rational equations. I should have taught you this beforehand, but they had us doing it in a different order. This is actually the lesson I should have taught before we did that. But because we've learned that, we will, huh? Pineview High School did at first. So Pineview High School decided what order we were going to teach it in, which was totally didn't make sense. They even abandoned it. But we're on a good system now. So we're going to add, subtract. So this is where we're going to start. We're going to start by adding something like this. X over x plus 3 plus x plus 2 over x plus 5. We want to be able to add these together. Okay? Now, By the way, let's review what a rational expression is. What is a rational expression? Say that again. Okay, that would be a rational number. Okay, so it has a turning decimal. Okay, this is used a little bit differently. A rational expression like this, like x over x plus 3 is a rational expression, and x plus 2 over x plus 5 is a rational expression. Now we're going to add these two rational expressions together. Rational, what does ratio mean? Comparing two things, right? It's a comparison of two things by division. Do you remember that? Ratio is a comparison of two things by division. And so when we have something like x over x plus 3, that's a comparison of two polynomials by division. That's what a rational expression is dividing a polynomial by a polynomial. So this left side over here, the x over x plus 3 is a polynomial divided by a polynomial, which makes a rational expression. And the x plus 2 is a polynomial divided by the polynomial x plus 5, so that makes a rational expression. And we're going to add these two together right here. So a rational expression has a polynomial divided by a polynomial, and you got to make sure that the polynomial on the bottom has an x in it. Otherwise, it's not a rational expression. It doesn't have an x in the denominator. So anything with an x in the denominator and there's no square roots, x's in square roots, then you've got a rational expression. Okay, so we're going to add these two together. Now, I want to go back and review a little bit about adding fractions. Let's say we have something like 5 over 12 plus 7 over 8. Okay? Let's say we want to add those together. Now, what is it we have to do to add two fractions together? Okay, we have to have a common denominator. So, now we could find a common denominator by multiplying 12 times 8, right? And that's what's going to happen a lot with rational expressions, but we want to find the least common denominator, which would be 24. 24 is the smallest number that 12 and 8 will both divide into, right? I always check, this is what I always do. I say, will 8 go into 12? If not, then I take the bigger number and I times it by 2. Well, you get 24. Now I check, will that 8 go into 24? Yeah, so 24 is our common denominator. So I write it like this, 24 and 24. And I think, okay, what would have I had to times the 12 by to get 24? 2. So I got to times the top of that fraction by 2 as well. 2 times 5 is 10. And what do I have to times 8 by to get 24? 3. So I'm going to have to multiply 7 by 3, and I get 21. And now that I have a common denominator, all I have to do is add the numerators. Then what would that give me? 31 over the 24. And, you know, you can check to see if it simplifies from there, but in this case it doesn't. So because the 31 is a prime number. So 31 over 24 is my answer. You could write it as 1 and 7/24 if you want. We're not going to do that with these rational expressions right now. We'll just leave it as improper fraction if that's the way it is. Okay? Now, as your task right now, I would like to see if you guys could add these two rational expressions together in your groups. So talk about it, work together. I'm going to give you a couple minutes. Go. Okay, it looks like most of you guys got this. Funny thing is, you guys started off. Most of you guys started off by thinking you had to just multiply the top and bottom by like a single number. But you guys, to get these denominators to be the same, you actually had to multiply, like the left one, you had to multiply x plus 5 by the top and bottom. So you should have had this over here. And then on the right side, you had to multiply the top and bottom by x plus 3. So you had to multiply the other ones by the denominator of the other ones, so to get the common denominator. So right here, our common denominator is x plus 5 times x plus 3, right? So if I multiply these out, and I'm going to write them above it. This is going to end up being x squared plus 5x. This one's going to end up being x squared plus 5x plus 6. Please don't, guys. And the common denominator is going to end up being x squared plus 8x plus 15, right? And so on the top, now that we have a common denominator, all we have to do is combine like terms. X squared plus x squared is 2x squared. 5x plus 5x is 10x. And 0 plus 6 is 6 all over the common denominator, x squared plus 8x plus 15. And that right there is your answer. It looks like most of you had that. Or some of you guys might have made a couple of mistakes when you multiplied. But you got the... Can you relieve the denominator as x plus 5 times x plus 3? Technically, yeah, you can. It just depends on what format you want the answer in and what format, like if you're taking a multiple choice test, what format the answer is in. It just depends. We could also see if the top simplifies and factors and see if there's any common factors, because I can see you can factor 2 out of the top. That would leave you the x squared plus 5x plus 3. That wouldn't factor. So, no, that's the answer right there. Okay? That's how you add. Now, subtract, you do the same way, don't you? When you subtract polynomials, the only difference is you're going to be subtracting. Let's do one right here. Okay, I want to go 2 over x squared minus 9 subtract 3x over x squared minus 5x plus 6. Now, you guys, you're looking at this and you're thinking, okay, I could multiply x squared minus 9 times x squared minus 5x plus 6 to get my common denominator. But you might not need to do that. What you do is you factor x squared minus 9 and factor x squared minus 5x plus 6 and see if there's already some common factors there so you don't have to have a huge denominator. Okay? So figure out what x squared minus 9 factors to be, because it does factor, and so does x squared minus 5x plus 6. That one factors as well. So do that. And then get a common denominator. Okay, you guys, if you look at this now, the factor that we're missing on the left side that we need to have is x minus 2, because our factors are x minus 3, x plus 3, and x minus 2. Notice that x minus 3 is in both denominators. Okay? They don't cancel out. We just don't need to multiply the other side by them because they already exist. But this one's missing x plus 3, so I've got to times the bottom by x plus 3. But that means I got to times the top by x plus 3, because x plus 3 is a factor over here. I got to have my denominators the same, right? Now over here I'm missing an x minus 2, so I got to times the top and bottom of this one by x minus 2. Okay? Yeah, we did kind of do this at the first of the year. So I've got the top and bottom, I've got to times by x minus 2 on this one. Now look, you guys, what is x minus 2 divided by x minus 2? It's 1. So really, did I change this fraction over here? I changed what it's looking like, but I didn't change the value, right? And what's x plus 3 divided by x plus 3? 1. So I didn't change the value of that one. But now I have, the denominators are the same. They each have an x minus 3, an x plus 3, and an x minus 2 in it, don't they? Both denominators are now the same. Okay? But I'm not going to times them out. Okay? On the top I will. 2, I'm going to distribute the 2. So 2x minus 4, right? And then I'm subtract all over the common denominator, which is x minus 3, x plus 3, and x minus 2. And then I'm subtracting this whole next part. 3x times x is 3x squared, and 3x times 3 is 9x. Okay? So I'm ready to combine like terms on the top. So I have 2x minus a positive 9x. What's 2x minus 9x, you guys? I got to combine like terms on the top. Okay, you know what? Let me just distribute this is like a -1. I'm going to distribute the -1 through. So 2x minus 4 times a -1 by 3x squared, and I get negative 3x squared, times a -1 by 9x, and I get negative 9x. All over the common denominator. X minus 3, x plus 3, and x minus 2. Now I'm just going to write my numerator in descending order of exponents. So my first one is going to be what? Negative 3x squared. I have the x's I need to combine because there's two of them. 2x and negative 9x make negative 7x minus 4 all over the common denominator. We could multiply them all together. Well, I know, first of all, that this is going to be x squared minus 9 times x minus 2. If I multiply the first two together. And if I FOIL, I got x cubed minus 2x squared minus 9x plus 18. And if I combine there's no like terms. So it's x cubed minus 2x squared minus 5x plus 18. And there is my answer right there. How many of you got that? Okay, come on. Good. And that's how you do that. Okay? Right now. You're using it right now. Okay. Say that again? Oh, that's because I can't read my writing over there, huh? That looked like a 5 to me when I was looking at it right there. So yeah, minus 9x. Okay. I can't read my writing. It's a 9. All right. Now, the good news here, you guys, is multiplication and division's easier. Okay? So we're going to move on to a multiplication problem now. Okay, multiplication. Multiplication, let's say we had this one right here. X plus 4 over x squared plus 5x plus 6. Multiplied by x plus 3 over x squared minus 16. Okay? Now, when you multiply two fractions together, let's go back to this. Let's go 5/9 times 7/8. When you multiply, all you have to do is multiply numerators together, right? 5 times 7 is 35. 9 times 8 is 72. Okay? There's your answer. Now, sometimes you might have something like this. 2 over 5 times 15 over 30, maybe. In this case, you guys, if you can write these as factors, like I can write 30 as 2 times 15. I know this reduces to 1/2, but for the sake of what we're doing right here. Actually, maybe what I had to do is write that as a 28. I'm going to do that. Okay. For the sake of what we're doing right here, I'm going to rewrite this one as 2 times 14, and this one as 5 times 3. Because you can cancel, when you're multiplying two fractions together, you can cancel any factor on the bottom with any factor on the top. When you're multiplying, not when you're adding or subtracting, but when you're multiplying. This 5 will go into that 5. This 2 go into that 2. And so what is my answer? 3 over 14. Because when this cancels out, it becomes a 1. So 1 times 3 is 3. 1 times 14 is 14, right? We should cross those two out because we changed the 15 to 5 times 3 and the 28 to 2 times 14. Do you see that? So if you can cancel like that, that's another good method. So right here, notice timesing x squared plus 5x plus 6 by x squared minus 16, that looks like a lot of work. But I see some stuff. I see that there's, if we factor this one and this, if we factor x squared plus 5x plus 6 and we factor x squared minus 16, we're going to be able to cancel like we did on this one. So I want you guys to factor these two and see what you can cancel out and then multiply the rest together, okay? Go ahead. Okay, looks like several of you have it. We're going to move on right here. This, what did this one factor to be, you guys? And what did this one factor to be? Okay, good. So now, since I factored those, I'm going to cancel those out. So what cross cancels here? The x plus 3's cancel, and the x plus 4's cancel. Remember, keep in mind when you cancel these that are 1, because you're really dividing. X plus 4 divided by x plus 4 is 1, right? And x plus 3 divided by x plus 3 is 1. So on the top, I have 1 times 1 is 1. And on the bottom, I have x plus 2 times x minus 4. And if you multiply those together, you get x squared minus 2x minus 8. How many of you guys got that? Excellent. Good job. See, multiplication's a lot easier than addition and subtraction of fractions, of rational expressions. Okay, last one. Last one. You know what's hard about fractions is you guys, I remember when I was in high school and we started doing rational expressions like this, it was easy for us because we already knew the rules to adding, subtracting, multiplying, and dividing fractions. But you guys tend to forget because you guys use your calculator most of the time for that stuff. And so you forget it. But if you can remember the rules to this, then it's not really that hard. You know how to find common denominators and stuff. All right, next one. I have x plus 4 over x squared minus 5x plus 6 divided by, you guys, x squared minus 16 over x plus 3. Now, do you guys remember how to multiply or divide fractions? What do you do? Like if I had something like, hey, you guys, don't flip those around, please. If you have 2/5 divided by, let's say 8/15. Okay? Well, you don't know. You only have to find common denominators when you add and when you subtract. Okay? Fractions. In this case right here, some of you guys are saying cross multiply. I like to do it this way better. I like to rewrite it as a multiplication problem. What would it be written as a multiplication problem? 15 over 8. It's the same thing. You can change a division problem to a multiplication problem by flipping over the second fraction and make it a multiplication. It's the same thing as cross multiplying. But in cross multiplying, sometimes people get confused on which one they put on top and which one they put on bottom. That's why I have you do this. Now look, I can see that 2 will go into 2 once and it will go into 8 4 times. And I can see that 5 will go into 5 once and it will go into 15 3 times. And so 1 times 3 is 3. And 1 times 4 is 4. And my answer is 3/4. Okay? Now, I would suggest we do the same thing up here. Okay? You're going to be able to switch it. You're going to be able to oh, you know what? Isn't this the same problem we just did? Okay, so it'll be a little bit different at the end. Okay, go ahead and do this one. Okay, so this one right here, we're going to have x plus 4, and then the bottom's going to factor to be what? And you're going to times that by this one flipped over, x plus 3 over x plus 4, right? And so the x plus 4's cancel out, but the x plus, there's nothing else that cancels out, huh? It's kind of a bummer on this one. So we have x plus 3 on the top, and on the bottom, we're going to have x minus 3 times x minus 2 times x minus 4, and for the sake of time, we're not going to multiply them together. And that would be our answer, okay? So, your assignment. Now, you guys, I've been doing this lately. I'm not always going to do it this way, but give you an assignment. We talk, do a couple examples on it. Let's do, okay? Okay, so we're going to do the same thing. So the one that we went over today will be due next time. The assignment I'm going to give you today will be due in 2 times, okay?